Okay, chapter 17. This one's only going to be 17.1. It's on the atmosphere. The case study at the beginning is about clearing the air in LA and Mexico City. Shows kind of the smog that there used to be in these cities. And if you go to LA now, it's actually quite clear, and that's really because of the Clean Air Act from 1970. But then some efforts began in Mexico City in the 90s, so the case study is worth looking at. Then we turn to page 452, where section 17.1 starts, which is the atmosphere. So the first thing you need to know are the percentages of the gases in the atmosphere. And this is on average between all the layers. So nitrogen gas, which is N2, is about 78% of the atmosphere. Oxygen gas, which is O2, is 21% of the atmosphere, and these are here. And the other gases are about 1%. But what you need to know is that that's not really evenly mixed and distributed throughout all the layers. Nitrogen is less dense, and so it rises to the upper atmosphere. So what we breathe in the troposphere, which is the lowest layer of the atmosphere, is mostly O2 because it is more dense. You need to know the layers of the atmosphere, and you need to add one up here at the top. The farthest one, or the fifth layer in this case, is called the exosphere, which is the outer layer. So down here, closest to Earth, is the troposphere. Then you have the stratosphere, the mesosphere, and the thermosphere, and then above that is the exosphere. You need to know all 5 layers in order from like the ground up. So this would be Earth right here, then this is kind of outer space. You need to know, the one thing you need to know about the exosphere is that it has the lowest atmospheric pressure because it has the least, it's the biggest space, has the least amount of gaseous particles in it. So it has the lowest pressure. This line right here is showing you, so here we have the altitude, so you're going up from the planet. The red line is the temperature. So in the troposphere, it gets colder as you go up. But in the stratosphere, it gets warmer as you go up. And in the mesosphere, it gets colder again. And in the thermosphere, it gets warmer. So that's actually how they define the layers, is by those temperature variations. You really should know these things about the troposphere and the stratosphere. So the troposphere is this layer down here at the bottom. This is where we live. It has the most air particles, has the most mass of air, has the highest density of air, and this is where weather patterns occur. Global warming is happening here. So basically everything on the planet that like we kind of consider life and living and related to that is happening here in the troposphere. There is one important thing in the stratosphere, the second layer, that you need to know. It contains what we call the ozone layer. So if you look, this blue right here is the concentration of ozone in the atmosphere. Ozone is the molecule O3. It is very, very big here in the stratosphere. So that's the ozone layer, and that's what protects us from the ultraviolet rays from the sun. So the rays from the sun come in and they get absorbed by this ozone layer and they don't make it down to the troposphere. So it protects us from sunburn and skin cancer and other, radiation harm. All right, then we turn the page to 454. You need to know what atmospheric pressure is. That's really just sort of the weight of the air particles pushing down on the planet. You need to know what relative humidity is. You need to know what convective circulation is. And we're going to talk about this a good bit in this section. You need to understand weather versus climate. So weather is what is happening on any given day. Climate is what you sort of expect to happen. That's about long-term trends, whereas weather is what's happening right then. You should know some weather terms. A high pressure system is when you have good weather. It's sunny, it's warm, fair weather. A low pressure system is when you have precipitation. So that's going to be rain or snow or anything like that. You should know this figure and caption right here for a convection cell. That's related to the convective circulation. What happens is cool, dry air sinks, and then it becomes, as it sinks, it gets compressed and it warms up. And now it's warm, dry air. And then as it moves kind of along the surface, it's picking up evaporated particles from water. It becomes hot, moist air that then expands and rises, and when it reaches here, it condenses and you have precipitation. And so then the cycle just kind of starts all over again. And so this happens all over the planet in regular places. We know where this happens. If you look at this picture over here, you can actually see where it's happening. So on this page, you need to know this figure and caption as well. And again, this is kind of showing you convection currents here, but it's showing you two next to each other. So you've got warm air rising and warm air rising, and then it's cooling down and it's falling, and it's cooling down and it's falling. And that's what's happening here. So we actually have these regions on the planet where the air is circulating continuously. And this sets up the wind belts that you're going to need to know, and I'll talk about on the next page. So there are deserts and arid climates at 30 degrees north and south latitude. So here's 30 degrees north, here's 30 degrees south. You can see that this is where the air is kind of falling down here, right? And if you think about over here, that is that dry air that's coming down in these areas. But near the poles, so it's the same thing here and here. But at the equator and 60 degrees north and south latitude, so here and here, that's where you have the wet air and the rain happening. So you actually do have areas of the planet, like the deserts are going to be located around 30 degrees north and 30 degrees south because of these convection current cells. Another thing that you should know is about thermal or temperature inversions, which is actually this picture over here, but this page was already full, so I stuck the stickies over here. This is when a warm band of air gets trapped between two cold air masses, and this will trap air pollution, and it tends to happen near the coasts because the ocean breeze kind of blows that cool air in and it goes under the warm air. So these are normal conditions. You've got warm air near the surface, and then it cools as it goes up. And so all of the heat comes in and radiates out, and all the pollution just kind of goes up and, dissipates into the atmosphere, which is not optimal. But then under an inversion condition, the cooler air is actually down at the bottom, and you have warm air, and it doesn't show it, but there would be a cool air here. So the warm is trapped between two cools, and the pollution isn't able to go up and escape. And so it gets just pushed back down, and you get this pollution. This is in like Denver, happens a lot, cities like that where it's kind of common. Okay, on page 456, talking about the Coriolis effect. You're going to do an activity on this. But this is the rise of warm air and the fall of cool air every 30 degrees of latitude, which we were talking about over here, which is a convection cell, plus the spin of the Earth. So the spin of the Earth on its axis deflects that air, and it causes winds and global wind patterns. And so if you look, the air is falling, but then the Earth is turning, and so it's actually forcing that air to move laterally as well as vertically. And so you get these patterns of wind that are constantly, well, not constantly, but like about every 30 degrees changing direction. And so you have these winds here that are the westerlies because they are going from west to east. So you have westerlies here and here. These are polar westerlies. And then in the middle, you have the trade winds. You have the north trade winds and the south trade winds, and they're going that way. That happens because of the Coriolis effect, and it causes all the global wind patterns. You should also know what hurricanes are. Obviously, in North Carolina, we know what hurricanes are. But they are called cyclones and typhoons when they happen in other parts of the world. You should know what tornadoes are. Those tend to happen really more not near the coast, but in the center of the continent. But that is 17.1.